Hello friends, in module 1 already we have studied introduction to operating system, system structures, operating system services and process management. Now let us start module 2. In this module there are 3 chapters are there. First chapter is multi-threaded programming, second chapter is process scheduling, third chapter is process synchronization. That first topic is overview. So just a brief introduction about multi-threading. So already we know what is a process. A process is a program which is in execution. Okay, a process is an executing program with a single thread. Okay, nowadays whatever the modern operating systems are there, and in those operating systems whatever the processes are running, those all processes are having multiple number of threads. So these multiple number of threads are present in processes which are running on modern operating systems. Okay, now we are talking thread. Okay, what is a thread? Thread is a basic unit of CPU utilization. It means how best you are utilizing the CPU, whether you are making that CPU idle or whether you are taking best use of that CPU. A thread is a basic unit of CPU utilization. Usually in CPU programs will be executing. If the programs are executing, it means that they are processes, and in each process they may be single thread or they may be multiple number of threads. So indirectly the processes are making that CPU busy, so indirectly the threads are making that CPU busy. So it is a thread is a basic unit of CPU utilization, and each thread is identified by a thread ID. So what all the other components of each thread? It contains a thread ID which is easily the thread is identified by that thread ID, and the thread also contains a program counter which stores the address of next instruction to be executed, and it also contains a set of registers, and at last it also contains a stack. So a thread contains thread ID, a program counter, set of registers and a stack. And the thread shares its code section, data section and some other operating system resources files and signals with other threads which are also belonging to the same process. It means that in a process there are multiple number of threads are there, and each thread shares its code section, data section and files with other threads which are also present in that same process. A traditional process has a single thread of control. It means in earlier days whatever the processes were there, they had only single thread, but now as I already told, the modern operating systems are running some processes. These processes have multiple number of threads, and if a process has multiple threads of control, it means that multiple number of threads of control means that it can perform more than one task at a time. Single thread means a, a process can perform only a single task at a time. A process which has a multiple number of threads means the process can perform multiple number of tasks at a time. So there is a diagram which clearly shows you the difference between single threaded process and multi-threaded process. See, this left side diagram shows a single threaded process, right side diagram shows a multi-threaded process. See, this in a single threaded process you can clearly observe the process has only one thread, and that thread has a code section, data section and some open files, and it also contains some set of registers and one stack. Okay, and it also contains of course thread ID which is not shown here. Okay, in right hand side diagram, in a same process there are three threads are there, and all of those three threads are commonly sharing a common code section, data section and files. For these three threads, code section, data section and files are same, but Each and every thread has its own set of registers and stack, set of registers and stack, and set of registers and stack. This is the difference between a single threaded process and multi-threaded process. Then what is the motivation? What was the reason we have started to use this multi-threaded processes? See, nowadays whatever the softwares we are using on our PCs, these all modern softwares are multi-threaded softwares. It means that software means what? It is a set of programs, and set of programs means once we start execution of those programs, they will become processes. So these all processes whatever we are using on our modern desktop PCs, they all are modern uh, uh, modern processes which contains multiple number of threads. Okay, a application is nothing but software is nothing but program, or program is nothing but you can call it as a process. Here a application or software is implemented as a separate process with several threads. Sometimes there are some situations where a single application can be or may need to perform some many number of different types of task. Okay. So what type of task? For example, a web browser is there, which is a application, and in that web browser one thread is busy in displaying the images or text which are coming from the server, and another thread may be busy in receiving the data from that server, and one more thread may be busy in other some other task. Like this, in a web browser there are many number of threads are there, and these all threads are performing different tasks. So indirectly we are calling it as a single application or single software can perform several tasks. What type of task? Different types of task. One thread is busy in displaying images or text which are received by the server, and another thread may be busy in receiving the data from a network or server, and another third thread may be busy in some other work, like this, and so on. And one more example is in word processor, or you can consider your Microsoft Office, Microsoft Word. In that application, one thread is busy in displaying graphics or text, and one thread may be busy in responding to keystrokes of a user, which is coming from the user side through this keyboard, and third thread may be busy in performing some spelling and grammar checking in the background, and some other fourth thread may be busy in some other task. Like this, in a single application there are multiple number of threads are there, and each and every thread is performing one particular task. Sometimes there are again some other situations, like a single application may be or may need to perform again multiple number of tasks, but these multiple number of tasks may be similar type of task. For example, web server is there. It is also an application which always accepts the request from the clients for web pages, images, sound and text and so on. And also of course it provides the services to these all clients. And a busy web server may have many number of clients which are present parallelly accessing this web server. Okay. If the web server runs as a single threaded process, it means if that web server is a single threaded process, then it will be able to service only one client at a time. Suppose if that web server is running as a multi-threaded process, then of course it is able to provide or service n number of clients at a time. Okay. If it is running as a single threaded process, then it is able to service only one client at a time. If so, then what about other clients? The amount of time that other clients are waiting will be longer. It means that all clients are servicing here, but not at a time or parallelly. All clients are servicing one by one because the web server is single threaded process. It means it can service or it can provide the service to only one client at a time. So one solution for this problem is we can make that server to run as a single process only, but it can accept multiple number of requests, and it can provide the service to multiple number of uh, requests of those clients. How to do this one? When the service server receives any request, it creates one more separate process to service that request. It means that when server receives a request, there is one particular process is created which is completely dedicated to receive the request from the clients. And after receiving that multiple number of requests, for each and every request it will create one separate processes to service that those requests. In fact, this process creation method was very much popular when there was no concept of thread. But nowadays, once this threads concept have come, so process creation method was stopped. Process because what was the disadvantage or a drawback of this process creation method? Process creation method was time consuming and also resource intensive. It means that so first of all, creation of a process took a lot of time, and once that process is created, so resources have to be allocated to that newly created process, resources like CPU time, memory, and so on. So it means that instead of creating multiple number of processes, we should always have a habit to create a multiple number of threads within a single same process. So it is more efficient to use one process which contains multiple number of threads. So this approach will make this web server example or web server process as a multi-threaded process. So the server creates a separate thread which receives or listens for a client request. When the request is made, instead of creating another separate process, the server creates another thread to service that request. Many operating system kernels nowadays all are multi-threaded kernels. Several threads operate in a kernel, and each and every thread performs a particular task, like managing the devices or interrupting the handle and so on. And now we will see what are the benefits of this multi-threaded programming. There are four benefits are there: responsiveness, resource sharing, economy, and utilization of multiprocessor architectures. We will see that first benefit of multi-threaded programming, that is responsiveness. Responsiveness means suppose if we are interacting with any application in our computer system, so we will call that application as interactive application. Okay, as a multi-thread, making that interactive application as a multi-threaded, it allows a program to continue to run even if the part of that program is blocked or that program is performing a lengthy operation, thereby increasing the responsiveness to that user. What it means? It means that whenever we are using an interactive application, and we want to make that interactive application as a multi-threaded. Earlier, if it is a single threaded, it can perform only a single task at a time, but now we want to make it as a multi-threaded process. So by doing like this, what we get, it allows a program it allows any program to continue its execution or to continue its running even though small part of that program is blocked, or else that small part of that program is busy in performing any lengthy operation, so thereby increasing the responsiveness to that user. The best example is a multi-threaded web browser can allow that user interaction in one thread, and another thread may be busy in loading the image on a screen. that image is coming from the web server. Means in a browser, one thread is busy in receiving the image or text from the server, and one thread is busy in displaying that text or image on a screen. And since that displaying of image, if it is taking a lot of time, then at the same time the user can be keep on interacting with the browser by typing any URL in address bar or something like this at a time. This application, which application, web browser application, can perform many number of tasks at a same time because of this multi-threading. Second benefit is resource sharing. So by default, as I already told, these threads always share memory and resources of a process to which they belong. It means in a process there are many number of threads are there, and the threads will share the memory and resources which are belonging to the same process. Okay? The benefit of this sharing code section and data section also allows an application to have many number of different threads to be present in a same address space or same memory. Third is economy. It means allocating memory and resources for process creation is costly, and since threads share the resources of a process to which they belong, it is more economical to create the threads. So for example, in a family, one father and one mother is there, and for this couple there are four sons are there, and at a childhood there was no any problem. And since it was a poor family, suppose they got any uh, uh, facilities from the government like Awas Yojana something, so government will provide only one house for the entire family. The government will not allocate one individual house for individual person of that family. Okay, so all those six members can accommodate in one house. Yeah. So you just compare that house as a process, and these family members, you compare them as a threads. It means that in a same process all threads are accommodated. Suppose after some time, if any one of those four sons, if he is not adjusting in that house, if he wants to make a separate house, at that time he has to construct his own house just beside that house, and of course it will take some extra amount. He has to purchase a new furnitures, new TV, new kitchen, everything. So it is economically burden for him. So same concept is here also. So for any new task, instead of creating a new process, so just create the new thread in a same process so that it will be economical. So once again we read this 2 points, that is economy. Allocating memory and resources for a process creation is costly, so instead of creating a process, we should create a thread. Since threads share the resources of the process to which they belong, it is more economical to create the threads. And last benefit is utilization of multiprocessor architectures. So single processor architectures are there and multiprocessor architectures are there in computer systems. Single processor architecture means a CPU contains only one processor, or in a system, computer system, there is only one CPU. In a computer system, if there are multiple number of CPUs or multiple number of processors, then it is multiprocessor architecture. The utilization of multiprocessor architectures, it means how best we are using this multiprocessor architectures. The benefit of this multi-threading will increase a uh, benefit of multi-threading will be increased in this multiprocessor architecture, where these threads may be running in a parallel on different processors. But in case of single threaded, in a single threaded process can run only on one processor or one CPU, even though there are multiple number of CPUs in that system. The since it is running only on a single CPU, the remaining CPUs will be idle. So to make best use of this multi-threaded architectures, So this all threads can be running on different processors parallelly, and multi-threading on a multi-processor or multi-CPU machine increases this parallelism at a time. So at the same time, a multiple number of tasks can be performed at a same time parallelly or concurrently. So in the next class we will discuss about multi-threading models. Thank you.